one of these ones. Let's do a half angle. Yeah, something like number 6. Okay. How intensely will this exam score affect your grade? It's 100 points. The total class is like 600 and something, or around that. I think it's like 15% roughly of your grade. But you could get like a 50% and it shouldn't hugely affect you if you're doing decently in the class. If you have a B in the class and you get a 50% on this exam, you should still be set to get a C or a B in the end. All right, so let's do something like here. Okay. So find the exact value using half angle formulas. So if we have something like, so there's 6a on the review. Sine of pi over 8. So we're going to use this half angle formula up here. Okay. So again, we have to identify what is our u and what is our 2u. So u is going to be our angle right here. And then 2u, right? If u is pi over 8, then 2u is 2 times pi over 8, which is just pi over 4. So the sine is equal to the plus or minus square root, and we choose, depending on the quadrant, pi over 8. That's first quadrant. Right, first quadrant, so positive. We're not going to use a negative. 1 minus cosine of 2u, and we said 2u was pi over 4. Over 2 is how we do something like this for the half angle formula. Okay? And then we just simplify. And this can take a while, right? Cosine of pi over 4 is 1 over root 2. And then we have to rationalize the denominator. Rationalize this denominator. Get rid of the complex fractions. There's a lot to do right here. All right, if we multiply by root 2 over root 2, that takes away the complex fraction. We multiplying the top and the bottom by the LCD. We don't like fractions inside of fractions. We distribute that. 1 times root 2 is just root 2. This becomes a minus 1, and your denominator becomes 2 root 2. And I will accept this like 9 out of 10 points just right here. But we can also make this a little simpler if we multiply the top and the bottom by root 2 over 2 again. Because that rationalizes this denominator and lets us do some nice stuff. So again, just distribute that out. Root 2 times root 2 is just 2, or the square root of 4. Minus root 2. The bottom becomes 2 times the square root of 4, which is 2 times 2, which is just 4. And now that's nice because the top we can't touch. The top is just 2 minus root 2. But the bottom is the square root of 4, which is 2. That's like a nicer way of looking at it. But right, if it were out of 10 points, this would probably be 8 points right here. If you got to this place, I'd give you 9 points. If you got to here, I'd give you the full 10 points. Okay, so most of the points are just using the half angle formula for a problem like this. All right. And it could also appear something like number 7, which I can talk about right after, unless people have other questions. On the review, if we're looking at something like number 7, number 7 on the review says, find the exact values of all of these half angles without solving for x. Okay. And we're given information about sine of x. So whenever you do this, you always have to start with the half angle formula. Okay. So for example, on number 7, let's look at tangent. We don't do tangent ones very quickly. What's the double angle? What's that? What's the power reducing formula for tangent? It's tangent squared of u. Pull it up. Right? Tangent squared of u is equal to 1 minus cosine of the double angle divided by 1 plus cosine of the double angle. Okay? 1 minus cosine of 2u divided by 1 plus cosine of 2u. So if we're using the half angle formula, we square root both sides. All your half angle formulas are going to have a square root like this. And again, this form is not on your identity sheet, right? The identity sheet only has this form. If you want to write all of these down, all three of these half angle forms on your identity sheet, go for it. Okay? Otherwise, you can just do one step to get them there. So what do we have, right? In our problem, we were asked, what is the tangent of x over 2? So u is going to be x over 2. Then 2u is double that, which is just going to be x. We get that the tangent of x over 2 is equal to plus or minus what sign? That's important. Okay. We need to know what sign. Is x over 2, what quadrant's x over 2 in? Is tangent positive or negative there? Think negative? Let's look at it. So we know sine of x is negative 12/13, and x is in the third quadrant. So we know x is in quadrant 3. We need to know what quadrant x over 2 is. All right, it's going to be in quadrant 2. And you can think about that graphically if you want. Or you can think about it with inequalities, right? If x is in quadrant 3, that means it's more than 180 degrees and less than 270 degrees. So to find out what quadrant x over 2 is, we just make this an x over 2. If we divide it there, we have to divide it everywhere. So that we get that x over 2 is more than 90 degrees and less than or equal to 135 degrees. So we know x over 2 is in quadrant 2. This right here is probably the hardest part of a problem like this. Because we need to know the quadrant to determine whether it's positive or negative. Okay. So it's in the second quadrant. ASTC, second quadrant, only signs positive in the second quadrant. So tangent is going to be negative. So you were correct in guessing negative, even if you didn't exactly know why. Okay. And then we just fill things in, right? This becomes 1 plus, we said 2u is the same as x. So this is going to be 1 plus cosine of x divided by 1 minus cosine of x. And again, something like number 7 really will be probably one of the hardest things that you can see on this exam. So we need to know what cosine of x is. So again, we look back at the problem. We don't know what cosine of x is, but we do know that sine of x is negative 12/13. Okay? Sine of x is negative 12/13. We're going to use that to find cosine of x. Oh, you betcha, trigonometry. So we know, again, let's go off to the side somewhere. We know the sine of x is equal to negative 12/13, and x is in quadrant 3. We need to use this to find out what cosine of x is. So we draw a picture. We just draw some random triangle in the third quadrant. Sine is opposite over hypotenuse. And again, the y-coordinate's negative, so that's where this negative comes from. Hypotenuse is always going to be positive. Use Pythagorean theorem. Let's say this is x. X squared plus negative 12 squared equals 13 squared. Solve for x. You're going to get the x is 5. Negative 5, since, again, x coordinate's negative right here. Sorry. Draw a triangle in the right quadrant. I know what x has to be, because now we know what the cosine of x is going to be. Right, so the cosine of x is the adjacent negative 5 divided by the hypotenuse 13. And we can plug this in now and solve. So cosine of x is negative 5/13. So let's plug that in. We get the tangent of x over 2 is equal to the negative square root of 1 plus cosine of x. Cosine of x we said was negative 5/13, divided by 1 minus cosine of x, which again we said was negative 5/13. Yeah, we got negative 12/13 from the original problem right here. Sine of x is negative 12/13. I should probably zoom in a little bit. Kind of small. Imagine actually being able to read the problem. Okay. Oh, I did switch the signs, huh? Thank you. Yeah, I have it right here. This should be a minus right here. This should be a plus. This should be a minus right here. This should be a plus. Since the angle is negative, or since the ratio is negative, it will turn out to be that way. Good catch. Thank you. Now we just keep simplifying, right? Negative out in front. Negatives cancel. This becomes a 1 plus 5/13. This becomes a 1 minus 5/13. And now again, we have complex fractions. We need to simplify the complex fraction. So we multiply the top and the bottom by the LCD. Just 13. We distribute that on the top. We distribute that on the bottom. So that's going to make some nice things happen. Hold on, my cat is clawing at my door. All right, when we distribute 13 times 1, it's just 13. And we distribute it to this term, right? They cancel. 13 on the top, 13 on the bottom, they cancel. We just have a 5. The bottom, distribute it to the 1, that's just 13. They cancel right here. Get 13 minus 5. And we just simplify again. We get negative 18 over just 8. Ooh. Ooh. You guys see what's going to happen? Right, if we keep simplifying, that's negative. Reduce the fraction. 18 over 8. Divide both sides. Divide the top and the bottom by 2 is 9 over 4. Both of these are perfect squares. So we get negative 3/2. What a nice final answer we get right here. Let me know if you have questions or a specific thing you want to see next. Hey. No. 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 All right. Otherwise, we're going to look at some more problems. So those are usually some tricky ones. We could recall how to do some verification problems. Remember, for verification problems, you just kind of start on one side and then work your way to the other. So we're looking at something like number 4A. verify the following. We're going to start with the left-hand side because the left-hand side is just, we can use an angle sum formula right now, right? Tangent of some angle plus another angle is what we have right here. Tangent of some angle plus another angle. Is it your birthday, Brittany? Happy birthday, if so. Number 8B, yeah, absolutely. Also a verification problem. All right. So for 8B, you have a couple choices on where you want to start. Oh, nice, nice. I would start with the left-hand side because the right-hand side already has a tangent squared. Right? The right-hand side is tangent squared times tangent. So really all we have to do is show that this fraction is equal to tangent and we'll be good, right? Because if this fraction is a tangent, then you just combine these two together and you get tangent cubed. So we'll start with the left-hand side and see what we can do with it. All right, so 8B. The left-hand side, right? That's the sine of 2 theta divided by 1 plus cosine of 2 theta times the tangent squared of theta. And again, we don't want to do anything with this tangent squared because we're trying to get this whole thing to be tangent cubed. So having a tangent squared there is already useful. We just want this to be tangent. One of the things that you want to look at for these verification problems is see where you're trying to go. And what do you need that you don't already have? Okay. So we have a couple ways to approach this fraction. One of the ways would be to use the double angle formulas. So I think double angle formulas makes the most sense to me, right? So double angle formula for sine, right? You just find it on your identity sheet. You will have these. Is 2 sine of the angle, cosine of the angle. All right. Get 2 sine of the angle, cosine of the angle. The bottom is 1 plus, we'll use the double angle formula there too. And now, and it will never really, you will never fail from using the wrong double angle formula for cosine. But some angles, sometimes some of these are going to be nicer than others. So we have to sort of decide which double angle formula are we going to want here? Because again, think about the fact that we want tangent. Also a reminder, I don't know the answer to this. So I'm just kind of going through it as I would expect you to go through it. So yeah, every single formula is going to have some squares in it. So right off the bat though, what I see, right, is look, we have a 1 in our denominator. If we eventually want tangent, there can't be a 1 down here. Okay. Also, I'm confused as to how this 2 is going to play out. So what I'm originally thinking, again, I don't know where this is going. I'm going blind with you guys, is I want to use one of these equations. Right? Because notice if I use this equation has a -1. If I have a -1, I already have a +1, they'll cancel. Again, you can use any of these. Literally any of these will work. And I can show what happens if you use different ones. But I think this one's going to be the easiest. 2 cosine squared -1, because then the 1s are going to cancel. We could use this one too. But it would be a little messier. So we're going to use the middle one. 2 cosine squared of u -1. And again, we have thetas here. Because now we have a +1 and a -1. These cancel. We're just left with 2 sine of theta, cosine of theta, divided by, they canceled. We're just left with a 2 cosine squared of theta. This is nice. Right? There's all products now, so we can start canceling. You can't cancel if there's addition and subtraction. You can only cancel if everything's factored and multiplied. So the 2's cancel, and one of the cosines will cancel with one of the cosines. And what are we left with? In our fraction, it's just sine of theta over cosine of theta. So sine over cosine's tangent. Tangent times tangent squared is that tangent cubed, which is exactly what we wanted to show. All right. So if you have follow-up questions, or if you want me to show you what happens if we use a different identity in the denominator, I can do that. Hopefully that answered Brittany's question. I think sum and difference was usually pretty good for some people. Maybe I want to review something a little earlier on in case people forgot it, something from 9.2. There's no lecture for the exam. I think both face-to-face and online classes are given 90 minutes for the exam. All right, if there are no immediate follow-up questions, I'm going to go all the way back to number 1. Okay, it says find the exact value of cosine of pi over 12. So again, almost your whole exam, with the exception of the law of sines, almost your whole exam is identities. Okay, so when you're looking at this, you should be thinking identity. Half angle formula is a thought. But if we use the half angle formula, on the right-hand side, we'd get double this angle, which is pi over 6. Oh, that works. So you can use half angle formula here. The problem is in 9.2, so they want you to use angle difference. You can use either. Angle difference or half angle. So I'm going to show you the start of both methods, and we're not going to finish it unless people really want to see the end. Right? So if you use the angle difference, you need to write this as a difference of angles. So pi over 12, right? That's going to be 4 pi over 12 minus 3 pi over 12. So we're kind of going backwards. And right, what is 4 pi over 12? That reduces to pi over 3. This reduces to pi over 4. And we know both of these angles. So we could use the angle difference formula here and say, okay, cosine of pi over 12 is just the cosine of pi over 3 minus pi over 4. And then we find our difference identity for cosine. Cosine of an angle minus another angle means we're going to take whatever's on the bottom, since minus is on the bottom here, is the cosine of the first times the cosine of the second, plus, again, whatever's on the bottom, sine of the first, sine of the second. So this becomes cosine of the first, which is pi over 3, cosine of the second, which is pi over 4, plus sine of the first, pi over 3, sine of the second, pi over 4, and simplify. If you wanted to use a half angle formula, you'd say, okay, cosine of pi over 12 is plus or minus, and we use plus here because we're in the first quadrant, 1 plus cosine of double the angle. What's double this angle? Pi over 6 divided by 2. And again, you could simplify this as well. So these are very different methods, but you'll get to the same answer. All right. It might look a little different though. Real quick, right? This is 1/2 times 1 over root 2. This is root 3 over 2, 1 over root 2. So you get 1 plus root 3 over 2, root 2. All right, and if you do it this way, again, feel free to ask questions. I'm just doing this kind of for my own curiosity. Cosine of pi over 6 is root 3 over 2. Multiply by 2 over 2. To get rid of the complex fraction, you get the square root of 2 plus root 3 over 4. Square root of 2 plus root 3 over 2. Are these the same answer? It should be, right? Let me just double check. 1 plus square root of 3 divided by 2 square root of 2. That's about 0.96. The other one is the square root of 2 plus the square root of 3 divided by 2. Yeah, they're the same answer. I think what you probably do to get them to look the same is you go back a step and get rid of this fraction. Huh. I might need to review my own algebra. Because it's weird. You want to get rid of the square root inside of the square root if you're going to do this. And I see the only way to do that is multiply by the conjugate. Oh yeah. You do it right here. Crap. The thing I erased. You multiply by the square root of no, I don't know. Anyway, that's something for me to learn some other time. But they are the same answer. And I will take both. Okay. There, I have homework. Other questions? Sections you think are worth talking about? Remember, you might get a I can maybe do a domain problem for the trig equations. There are probably not going to be any application problems on this test. No. I can here. Let me just check. I'll check real quick and get back to you. Yeah, there are no application problems on this. Everything on the exam is looks like something from this review. All right, so reminder though, if you do get something like these ones are kind of weird, like 13D, right? These ones are kind of strange. If you have something like 13D, oh, also for extra credit, if you want extra credit for attendance today for the face-to-face class, send me in Discord a kind of weather: snow, rain, clouds, wind, sunny, moderately cloudy, some kind of weather for today's extra credit question for the face-to-face class. 13D says solve in 0 to 2 pi. Okay, and the equation is 2 times the sine of 3 theta equals 1. So these ones can be tricky too, right? Again, first step is always solving for the trig function, right? So this one, you divide both sides by 2. This one, you divide both sides by 2. You want to get that trig function by itself. This one, you add 2, then divide by 4, and then take the square root. And remember, when you take the square root of both sides of an equation, you need a plus or minus. That got some people on the quiz. This one, you divide both sides by 2. This one, you divide both sides by 2. This one, You got to use some trig identities and simplify. Probably write secant as 1 over cosine, and then you have tangent minus 2 sine. And, oh no, this one you factor. This one you factor. You factor out a sine from both sides because it's set equal to 0. You can factor it, then you just solve each one individually. Okay, and so on, so on. All right, so over here, we need to divide both sides by 2. We get sine of 3 theta equals 1/2. So we're going to use a substitution and say, let's not worry about theta for a bit. Right? Let's let x be 3 theta. So then the question is, what is the domain of x? Right, we know theta is between 0 and 2 pi, but what is x between? Right? If theta is between 0 and 2 pi, x is just 3 theta. So 3 theta, I did it again. 3 theta is going to be between 0 and 6 pi, and that's x. X is 3 theta. So we're going to look for all the values of x between 0 and 6 pi. So we're just going to find the main ones and then do a rotation to get another pair and another rotation. Everything in the first 3 rotations of the circle, 0 to 6 pi. All right, so we need to find, okay, what's our reference angle? When is sine equal to 1/2? That's going to be when the angle's pi over 6, and you'll have your reference triangles on the exam. Yeah, there's going to be 6 answers for this one. Good. I'm glad that you already recognize that. So, and then again, we need to figure out what quadrants is sine positive in, right? It's equal to a positive 1/2. We need to find what quadrants the sine is positive in. We get 1 and 2. So then we need to find the angles with a reference angle of pi over 6 in these 2 quadrants. And find all those coterminal angles in the first 3 rotations. So reference angle of pi over 6. This is one answer, pi over 6. Another reference angle of pi over 6 is over here. And that's going pi units minus pi over 6, just 5 pi over 6. Okay. So what do we get? We get that x is equal to pi over 6, 5 pi over 6, and these are only the answers for x, which again, x is between 0 and 6 pi, in the first rotation. But we have to do 2 more. We have to find 2 more pairs of complementary angles. So, right, you're going to be adding 2 pi, and remember 2 pi is 12 pi over 6. So add 12 pi to 6 over there, 13 pi over 6. 12 pi over 6 to this, 17 pi over 6. 12 pi over, another 12 pi over 6, 25 pi over 6, and another 12 pi over 6, 29 pi over 6. And those are our 6 answers for x. And again, if you get this far and then mess up, I'm only going to take off 1 point if you don't go any further. But remember, we were asked, always a good habit, before you box your answer, it's always a good habit to go back and say, what is the question asking? The question is asking, what is theta? Right? So remember, we said x is 3 theta. Right, so this is 3 theta. So to find what theta is, we just divide everything by 3. Okay? Divide everything by 3. This becomes pi over 18. Divide this by 3. 5 pi over 18. Divide by 3. 13 pi over 18. 17 pi over 18. 25 pi over 18. 29 pi over 18. And these ones are pretty tricky too. All right. Other questions, either on this or some other problem that you want me to do? I think one of the main sections we haven't covered yet is law of sines, but that's pretty recent. I think most people will be good with law of sines. All right, where did I lose you, Brock? There's a lot of places to get lost in this problem. Again, I am intentionally choosing difficult problems today. How did I get these answers or this answer? The x's or the thetas? Yeah, the thetas is dividing everything by 3 because we don't care about x, we care about theta. So essentially we're solving this equation. Oh, okay, your question's on the first set. So first off, ignore these 4 answers. We'll just look at these ones. We're solving the equation, when is sine of x equal to 1/2? We consult our reference triangles to get that this is true when x is pi over 4 or pi over 6. It's because sine of pi over 6 is 1/2. Then we say, okay, sine is positive here. So what quadrants is sine positive in? First quadrant and the second quadrant. That's where this pi over 6 comes from. In the second quadrant, that's pi minus pi over 6. Just 5 pi over 6. And that's where the second answer comes from. Now the other 4 answers are more complicated. Okay. Remember, we said that x, if theta is in 0 to 2 pi, x is between 0 and 6 pi. So again, these 2 answers are just the answers in 0 to 2 pi. But we need 0 to 6 pi, which is the first 3 rotations of a circle. So what we added 2 pi to pi over 6, and we got that. We added 2 pi to 5 pi over 6 to get this. 2 pi to that gives that. 2 pi to that gives that. And these are all the answers in 0 to 6 pi for x, after which we solve for theta. Okay. And so to quickly get these answers, we added 2 pi, which is 12 pi over 6. That's where we got 13 and then 25. Good. Thanks for asking. Any other questions? We can maybe do one more problem today. I want to do an ambiguous case for law of sines. 29 pi over 18 is less than a circle? I sure hope so. And the way that you know that, jokes aside, is we know this is less than 2 pi. Because 2 pi would be 36 pi over 18, right? And our numerator is less than 36. Yeah, exactly, Alex. That's another good way of saying it. All right. Other questions? Go ahead and ask them. Otherwise, I'm going to look at something from 14, law of sines. I'm going to try pick an ambiguous case. Like maybe E. Say we have some triangle, alpha, beta, gamma. And in E it says B is 13. B is opposite beta. C is 5. C is opposite gamma. It also says that E, gamma is 10 degrees. So we use the law of sines as a sine of gamma. Because again, for law of sines, we always want to pick a pair of a side and the angle opposite that. So that's 10 degrees and 5. The sine of 10 degrees over 5 equals, now we need to pick a pair with an unknown, b and beta. We get sine of beta over 13. Multiply both sides by 13, you get sine of beta equals 13 times the sine of 10 degrees divided by 5. You type that into your calculator to get an idea of what you're dealing with. 13 times the sine of 10 degrees divided by 5. It's approximately sine of beta. It's going to equal 0.4515. And now we need to use inverse sine to find out what beta is approximately equal to. And remember, for the law of sines, there are some ambiguous cases. So this tells us that beta is approximately equal to 26.8400 degrees. But remember, that's only one solution of this equation, just like before, right? We said sine of x is 1/2, so x is pi over 6 or 5 pi over 6. Well, this is only one answer of this equation. The other answer is beta prime, which would be 180 degrees minus that, just like how we got 5 pi over 6. All right, so beta prime would be supplement 180 minus 26.8400. That's 153.1600 degrees. And the question you have to answer in these ambiguous cases is, does this make sense? If this makes sense, we have two answers, and we need to draw two triangles. If it doesn't make sense, then we get rid of the primes and only solve this original triangle. All right. So we look at our triangle and say, well, 153 degrees and 10 degrees, that's not over 180, right? Gamma plus beta prime is less than 180. And beta, sure, that can be the biggest angle in this triangle. So it makes sense. So you're going to have two triangles to solve. So we have this one triangle where beta is 26.8 degrees. And then we have a second triangle where we have alpha prime, beta prime, gamma is still 10 degrees. This is still 5, this is still 13, but now beta prime is 153 degrees. All right, so you have to solve both of these triangles, and we don't have time for that today. That's how you'd proceed with something like this. This is really the worst case scenario for these law of sine questions, but it might pop up on the exam. I can almost guarantee, not an actual guarantee, but almost guarantee that your exam will have some ambiguous case, either with two answers, one answer, or no answers. All right. Yeah. Nobody likes ass triangles. Side angle triangles. But again, the order that all that matters is that side is on this side, side is on one side, angle's on the other. You can flip this order and it works. Yeah, that's where ass triangles comes from. Anyway, that's basically it. I will be available on Discord to answer questions as you're coming up and preparing for the exam. So feel free to reach out in the Discord if you have questions. All right. Let's see. I will make sure to also be online during your exam, so you can ask questions while you're taking it as well. And it should be just about it. If you want to schedule a time to talk about things, we can schedule a time as well. But usually I'm not, the only places I go right now are like outside for hikes and biking and stuff. So I'm usually within earshot and can get back to you within a reasonable time frame. All right. I believe that's true anonymity. I will double check for the exam open and close times. Yes, that is the case. And you have that time to do it. Actually, I'll extend that a little bit, just to give a little bit of wiggle room. There you go. All right, any other questions before I get off for the day? All right. Have a good day, you too, Ashton. Good luck, everyone. We'll start 10.2 on Friday. 10.2 should be even a little simpler than 10.1, okay? Bye-bye.